recording. Okay. So what are we doing here is we're continuing on where we left last week. So let's start with the topic of how we can store the objects created out of our own classes into data structures. And I'm just writing an example class here. This is what we did last week, basically. And we are going to write an str method for the class to return a representation of the state of the object. Something like this should be fine, I think, and then let's try it out. So let's create a student object, something like the name of this student is Simon. The ID is 1, 2, 3, 4, 5, and Simon has 45 credits. And then let's see that the str function also works. So when we print it out, we get the name Simon ID 1, 2, 3, 4, 5, and 45 credits. So it seems to be working. So what we're going to do is create a couple of objects. And 5, 4, 3, 2, 1, and 110 credits. Let's create one more. James, and the ID is all 9s, and James only has 11 credits. And so what I'm saying that we can store these objects into a list if we want to, like we did with any of the objects beforehand. So let's have a list called students, or let's have a variable called students, and then create a list, and then we just store the references of these objects into a list. So what it means in practice is now that for all these three objects, we actually have two references. We have these variables S1, S2, and S3, and then we have the items in this list students, which are also references to same objects, which means that if you want to print the name of one of the students, we can do something like let's get item 0 from students list and then get the name of that student, for example. So this returns the name Simon. Or if you want to output the names of all students in a list, we can do something like for student in students, and then let's print name of all those students. So we get the names of all students, or if you want to get the IDs of all students, we can do something like this, or we can also output all of the student objects like this. So we're basically calling the str method for all of these to get the representations and then output this. So there is actually nothing new here again. So what's happening is that we are just storing items into a list, and like we found out before, whenever we are storing something into a list, we are not storing the actual objects, but instead we are storing references to actual objects, like in this case, and then we can use these references to access the actual objects. So what it means in practice is that if I change one of these student objects, let's say I do something like this. Let's say that I want to give the first student more credits. So I increase the credit count by 10. And then when I output, well, let's do this again. Something like this. And then when I output it, we can see that now Simon has 55 credits instead of the original 45. So it doesn't matter whether we are using the S1 variable or the reference stored into list, we're still accessing the same student object somewhere in the memory. So exactly like we did with lists, for example, we in the introduction course, we found out that we can have several references to same object, and it doesn't really matter which of the references we use because we are still accessing the same object. And the same applies here. So we can also do something like this. And now Simon has, instead of 45 credits, Simon has now 65 credits because we are using both these two references to access the same student with name Simon somewhere in the memory. Okay, let's find out something else. What happens if I output the list of students like this? So let's execute this one. And now, instead of getting the string representation of each of these objects, I'm again getting this main student object that, and then some kind of hexadecimal address or code or whatever it might be, which isn't really useful because it doesn't give us any information about the content of the object. And the problem in Python, and this is sort of unfortunate in Python, it's a design thing, but in Python, when you're outputting a list, it doesn't call the str object. Instead, it calls the str method. Instead, it calls a method called repr, which is shortened for representation. And again, you can see that the Visual Studio Code does it for me if I want. And the basic idea is that in this case, we also return a string representation of this object. If we look at the Python definitions, the Python, like the formal definition of language, it says that the repr, however we pronounce it, the representation method should return a string which we can use to create a new similar object. So basically it should return something like this, for example. This is really a typical format to use for this one. So now when we execute the code and when we output the students list, we can see that now we get some kind of somewhat meaningful representation of each of these objects. So, as I said, now this is like the official way to use this one. So we can use this as a constructor call to create a similar object out of this class. Excuse me. So this is like the official way to use it. You can use something else in other occasions. If, for example, if you're outputting a lot of lists and you don't think that this represents the information you want to, then you can change it. It's not that big of a deal, but this is like the official way to use it. This is how the Python sort of, or Python designers want you to use it. Anyway, the main thing here is to realize that the str method may not be enough because for example, when you're outputting a list or dictionary or tuple or anything like that, they are calling this repr method instead. But the idea is the same. It just returns a string which represents the contents of the current object. Okay. Then let's move on. Well, I talked about that we're storing the items as references. We can also use, of course, use object as parameters. So we can write, for example, a function just outside of the class, something like output student name. And let's have a student type is student as an argument or parameter, and then we just output the name. So it's not really useful method, but anyway, it shows that we can use our own object as arguments if we know how to spell print. I apparently don't. Like this, yeah. So when we call, well, what will the program output? At least think, even if you don't want to answer. So the program passes this object, student object, as an argument for this function output student name, and then it outputs the name of the student. So it outputs Simon. And if we provide, for example, a different object like this student object, then it of course outputs James. So it outputs the name of the object provided as a parameter. Okay, we can also write methods in classes which get an object created from the same class as an argument. And let's write a method called better student, for example. And the idea is that we want to compare the current object to another student. Something like this. And the reason I'm writing this student, this type hint in quotas, is that because I'm working inside, or we're writing this method inside this student class, Python doesn't recognize that the class exists. So if I try to write it without these quotas, then Python adds this underline or stating that it's not defined. So to get rid of the error, we just use the quotas around it. It still provides the information we want to, that we want to pass another student as an argument. And then what we want to do in this method in this case is we want to compare the two students and return the better one. So let's see if the current student has more credits than the student provided as an argument, then let's return the current student. And we can do it by just returning the variable or using variable self and returning the value referenced by that. So this basically, what this means is that we are returning a reference to the current object. Let's see how it works in a minute. And if the number of credits isn't higher, then let's return student 2. So let's compare Simon to James, for example. Oh, I'm missing something here. So what will the program output? There's a lot happening here now, but what will the program output? Yeah, I think it outputs Simon, and it outputs Simon because Simon has sorry, I was supposed to compare him to James, as I said. I just mistyped, so it outputs Simon. You're right. If I compare Simon to Anne like this, and then as we saw before, then it outputs Anne. So we have a method where we compare the current object to another object from the same class, and then we just return a reference to the better one. And what's important here is the fact that we can use the self variable like this. We can return self, which basically returns the reference to the current object. So in this case, if the object referenced by S1 is the better one, better in a sense that it has more credits than the other object, then it returns the reference to S1, and if it isn't, then it returns the reference to S2. So this is useful in some occasions. The fact that we can actually use self like this, the fact that we can reference the attributes of the current object is also useful, always useful. But the fact that we can also use it in a return statement like this is sometimes useful as well. Okay, then what else? We can also store objects inside other objects. And let's see an example of this one. Let's have yeah, good question. Is there any difference if we passed S1 as an argument and not call the method on S1? It is in a sense that we are referencing because we are calling it from S1. We have the access to the attributes of S1, and then we can just provide S2 as an argument. We could have of course, we could have a function, something like better student, where we would have two student objects. I'm not going to write it right, but similarly, where we could have two parameters which are both type student, and then use it something like this, and then just compare which one is the better, and then return that one. And actually, in this case, this might be more logical, but the upside of this one is that we're always comparing something to the current object, which might be useful if we have, for example, if we have a lot of students which we want to compare to the current object. So it might be easier to do it like this. Anyway, the logic in this one is that we're always doing the comparison towards the object we have in here. Having here in the method call. So we're always doing the comparison towards S1 in this case, because we're calling the method by using the reference S1. Okay, then what I was talking about was the fact that we can also use object as attributes in other classes or in other objects. And let's write something like a, what did we have here? A completed course is actually quite nice for this one. So we have a class that models a completed course. And we're going to have a constructor, and in this constructor, of course, we have a variable self, and then let's say that we have a name of the course. We could have a course class, but in this case, let's decide that we only want to have the name of the course. So course is a string, and then we have the name of the student who has completed the course, or not just the name of the student, but the actual student object. So the type is student, and then because the course is completed, we probably want to have a grade of some kind like this. And then just again, let's set the values of attributes based on the parameters. Like this. And then let's decide that we don't need anything else at the moment. We could have the str and maybe repr methods and whatever. But let's decide that in this case we don't really need this. Okay, and so how it works? Let's have just going to need one student, and then let's create a course completion object. No, it was completed course. Let's just remove the import over there. And then when we create a completed course object, we need to provide the name of the course. So the name is Intro to Programming. And then the student, let's use Simon. And then Simon received 3 as a grade for the course. So now instead of creating like storing all the student data in this class, like having student name and ID and and total number of credits and so on in this class as attributes, we can have the entire student object as an attribute for this class, which is really useful because it's logical to store the student data in the student type object, but it's also logical to have the student information in the completed course object, and then we can just use the student class for this one to store the data. So now if you want to see which course was completed, we can of course get the name of the course. We can also get the grade. And if we want, we can get the entire student who completed the course, which just outputs the student object. So basically we get intro to programming and 3 as a grade, and then the student object. Or if you just want to get the name of the student, we can call the name or get the name attribute from student. So basically we get sequence or this sort of chain of completed.student.name, which means that we get the name of the student who completed this course in this from this completed course object, which has a student type object stored, and then we can call the name of the student or get the name of the student by using the attribute name from the student class. Something like this. Okay. We've talked about the none keyword before, I think. And again, it's important when we're creating our own classes, because again, the keyword none denotes that there is no reference. And let's see how it's useful. Let's see this better student method. So let's say that we want to, when we are comparing the two students, we actually want to get the one with more credits than the other. So in this case, if you look at the if-else comparison here, if they have an equal amount of credits, then it also always returns student number 2, because in that, if the credit number is equal, then the credits of the current object is not greater than the credits of student 2. So let's change it a little. Something like this. And now if neither of students is better than the other, we can return the none keyword. And let's also return it like this. And the idea is that that there is no better student. So let's return the none. So let's try it out. Let's say that Anne and Simon have an equal amounts of credits. So now if we compare what was the name of the better student to S3, and then let's output that one. We of course we get Simon, because Simon has more credits than James. But now if we compare Simon to Anne, we get none as a response. And none means, as the name sort of implies, that there's no value for that variable, or no value in this case for that return value. It's like a missing value. And we can use none as when we're creating variables, for example. I can do something like result equals none. And now we have a result type variable. It doesn't have a value. It also doesn't have a type, but we can later assign a value into it. Anyway, the variable does exist. So we can use the variable result without getting any errors, but it just doesn't have any value. And similarly, the variable better in this case doesn't have any value, because this better student method didn't return a value. It returned like an empty value none. And this is something you need to take into account. Let's do something a little different. So let's again compare Simon to James, and let's output the name of the better student like this. And when we output it, we get Simon. What happens if I compare Simon to Anne and try to output the name of the better student? If you look at the code in there, what do you think will happen? So if we execute the code now, see that we get an error stating that non-type object has no attribute name, and this is because non-type object actually is an empty value. It doesn't have any attributes, and it doesn't have any methods, and it doesn't even have a type. So it doesn't really output none, but instead it provides an error stating that it doesn't have any attributes. So it means that in this kind of case where the return value can be something like a none, we can check that that the better actually exists like this. So now when we execute this one, we don't get any output. We also don't get any error. But if the object does exist, then it outputs the name. So in Python, we can use an object as a comparison like this, as a comparison expression like this, even if it's not a Boolean type. So what happens here is that if this is a non-type, then this is false, and if it isn't, then it's true. We can also type something like if better is not none, which might be actually easier to understand if you're not that familiar with Python syntax. So nothing wrong with doing it like this, but this is effectively same thing. So if the value of better is something other than none, then this is true, but if it's none, then it's false. Okay. Then let's talk about something we discussed briefly at last time. So in encapsulation, and the concept of the encapsulation was that the whole idea of object-oriented programming is sort of hide some things from the client. And the idea is to make using the objects as simple to client as possible. Another important thing is that we want to preserve the internal integrity of the object, which basically means that we don't want the object to go in a state which is impossible for that kind of object. And what I mean with that is, let's see an example. Let's get rid of all this at the moment. We can also actually get rid of this one at the moment. Let's just have a student class, and let's see what happens. So what we saw before is that we can increase the number of credits of a student. So we can let's create student again. Let's have Simon once more. And 1, 2, 3, 5, 4, for example. And Simon has 55 credits initially. So if you want to add more credits, we can do something like this. And we saw before that this works as intended. Of course, we can set the number of credits to be something like 100. Say that Simon has done well today. But the problem with this one is that what happens if I do something like this? Well, this is sort of easy and this is sort of obvious. So I can set the value to -100 if I want to. And this is problematic because now it breaks the state of the object. The internal integrity is not preserved in this case because, well, nobody can have negative amount of credits, regardless of how bad of a student you are. You can't have less than 0 credits. But like this, we can't really prevent the client from setting the number of credits to a negative value. And this is problematic in a sense that the client may not do this on purpose. This might be like an accident. Maybe the client is reading data from a file or something and setting the values of object based on those, and there might be an error, or the client is reading like wrong column from a file, or whatever is happening. And now in this case, the client may not realize that there's an error happening, and we need to have some kind of mechanism to prevent this. So what we can do in Python is that we can create, maybe have a slide for this one. We can hide attributes. We can have sort of like private attributes in a class. And to create a private attribute, what we do is we add 2 underscores in the front of the name of the attribute. So instead of credits, we want to call it credits with 2 underscores. Now, the easy way to change this, because we're using the attribute in so many places, we're using it in STR and REPR and better student methods, is just rename it, and in Visual Studio Code, you can just click F2 and then give a new name to attribute, and then you can see that it changes it in all these occasions. You can change the name of any attribute. If you want to call the ID a student number instead, and it's easy like this, then it changes it in all appropriate occasions. So this is a really useful feature. Anyway, let's call it ID because ID is great in this. But now the credits, and now let's see what happens when we try to access the number of credits. And now Python gives us an error stating that student object has no attribute credits like this. It also doesn't have an attribute credits like this. So now we can't access the credits. So, okay, this doesn't really solve our problem. I mean, in a sense, yeah, we did hide the attribute from the client, but we might want to, it's likely that the client actually needs the information about the credits at some point. So we need to provide a service for the client, which the client can use to actually access the number of credits. And we can use it by writing something called the getter method. So getters and setters are like special kind of methods which we can use to read and write the values of attributes of an object. And to write a getter, what we do, well, let's first write a method. Let's call the method credit, because that's a sort of self-explanatory name for that one. And then we just return the value of the hidden attribute. And we also are going to annotate this with the DAC property, which means that it tells is a function to be used for getting an attribute value. Well, I don't know if that's actually useful, but the idea is that now we have an attribute which we can use for this one. And the attribute is called credits. It's the name of this method here. So now when we execute the program, we actually get 55 as a result. So now it returns this value here. The upside of this, of doing it like this, there are the one is the encapsulation, but the other one is that it's also about the encapsulation, is that we can sort of we can return whatever we want. So if we decide that all students have 5 credits more than stored in this credits attribute, let's say that everyone gets 5 credits just for participating in something in our fun university, then we can add 5 to all returned number of credits. So in this case, it returns 60. So we control the value returned to the client inside the class. Okay, the client can still, if you try to change the number of credits. there's still an attribute error stating that can't set attribute. So we have protected the attribute, it cannot be set. And this is useful for some attributes. For example, student ID can be something like that. It's like that the ID of the student doesn't change after the object is created. Names can change and number of credits can change, but the ID doesn't usually change. But the number of credits can change, and that's why we want to have a way to change it. We want to provide a service for changing it for the client. So let's write a setter method. Again, it's called credits. And we want to provide the number of credits for this one. Let's call it new credits for clarity. And what we do is what we change or set the value of attribute to new credits. Let's also have a type in for that one. And then we also want to have the stack for this one, and what we're going to, what is it? We call it's credits, and it's a setter for credits. So the property for this one, or is it here we use a property, and the attribute for this one we use is a credits.setter. So this reference is the name of this method here, and then the setter tells us that we are now setting the value. You can have a getter method without having the setter method like we did before, but you can't have a setter method if you don't have the corresponding getter method, this property in here. Okay, so let's see if it works now. So yeah, now we can set the number of credits to be 100. I'll get rid of that +5 in there. So we can actually see that the number of credits is now 100. So what is the upside of having this setter? I mean, we did all this work and now it just seems to be working like it did before. Before we actually had a private attribute and getter and setter, when we just had a like a public attribute. So why did we do all this work? Now the upside of this one is that we can write any code in these methods. So we can check that the number of credits provided by the client is acceptable. So let's find out that if new credits is larger than or equal to 0, then let's set the credits to be the new credits. So now if the client tries to do something like set the value to be -100, it doesn't change the value, it's still the original 55. But if the client provides an acceptable value like 100, then it changes the value. So encapsulation means that we hide details from the client and also that we protect details from a client. So we control what can be set as the value of an attribute inside the class like this. We could have I mean, taking credits away from someone doesn't really happen. So we could decide that the new value needs to be larger than the existing amount of credits also. So if the client tries to set the number of credits to 30, then again that isn't accepted, but 55 remains in this case. However, whatever we decide is the appropriate rule for this one. But let's decide that there might be, in some occasion, it might be useful to be able to also subtract the number of credits. Maybe there was an error or something like that, like this. Now, if the client provides an inappropriate value for this one, or like unacceptable value, we can either do nothing, or then we can decide that it's a good idea to notify the client that the value isn't acceptable. So we can, for example, raise an exception. Value error is great for this one. Something like this. So now if the client tries to set the number of credits to be a negative value, then we get an error stating that number of credits must be a positive integer, which might be useful. So it might be useful to notify the client that they're doing something wrong. They're trying to provide a value which isn't acceptable for this kind of object. So then the client can fix the code on the client side. Okay, let's have a couple of more examples. So we probably want to provide, let's say, the name to be private as well. And not all attributes need to be private. Not all of them need to be hidden. If you have an attribute where it's perfectly fine to set the value to anything, then and it's perfectly fine to read the value as well, then there's really no point in making it private. So making it private is useful if you want to sort of protect the attribute, like we do with the credits. We don't want the number of credits to be a negative value, but if there's something that can be changed, like a name, for example, it's difficult to come up with rules for names, but still. So if you don't want to protect it, then we can keep as it is. But let's say that we want to have some kind of rules for what the name can be set. So let's again change this to a private value by adding 2 underscores, and let's have a getter for that one. So again, we return the value of name, and then we announce it to be a getter like this. And then if you want, because people's names do change for various reasons, we can also have a setter for that one. So let's set the name to be the new name. And then again, let's have the annotation for this one. Not property, but name.setter like this. So now we can, again, this isn't useful in a sense that this is exactly similar to just having a public attribute, but we can have some kind of rule for this one. For example, we can check that the new name isn't an empty string, for example, because name can't be empty. And maybe there can be some other rules, something like the length of the name. Length of the name needs to be more than 1 character, I think. I mean, it can be 2 characters, but name probably can't be just 1 character. Or I don't know, maybe it can. Let's just assume that the length of the name needs to be more than 1 character, which is sort of implied for the fact that it can't be an empty string already. So maybe that's enough rule for that one. And for ID, we can again decide, let's make it private as well. We can decide that we don't want to provide, we want to have it's useful that the ID can, client can read the ID. So let's have a getter for that one. And again, let's have the annotation like this, but let's not provide a setter for that one, because ID, your student ID doesn't really change. The whole idea is that you're given one student ID when you start in an institution, and then you're sort of stuck with that ID for as long as you keep studying that university or that school. And when you go to another school, then you can probably create another student object anyway, because then you're going to have a different amount of credits and so on, and whatever. So this could be probably something that works. So what you need to think whenever you're writing attributes is that, do you want to provide a read and write access, or read access alone, or neither do the client? There might be some occasions where it might be useful to hide all the access to the attribute for the client if it's something that just used for the class, like the internal use of the class, some kind of other ID which you actually need for something, but you don't really want to provide that for a client, then you can have an attribute that the client can't access. So you just hide it with 2 underscores and you don't provide to getter or setter, and then the client can't access at all. Now, something you need to realize in Python is that it is actually possible to access these private values as well from the client side, but again, it's meant as a notation, and it isn't straightforward. You can Google it if you want to, how to do it, but it's to tell the client that the client is not supposed to access the attributes themselves, and even if they want to, they can't do it directly. They need to use a sort of a special kind of trick for that one. Okay, what else? We talked about getters and setters. We talked about this one. We can also hide the visibility of methods. Or change the visibility of methods, so we can hide methods from clients. So let's say that we have some kind of method which we use internally to check if an ID is okay or ID is available, for example. So we can check the database or something. So let's call it ID okay. And self an ID is an str, and then it's let's just say that the length of the ID needs to be exactly 5 characters or something. And if it isn't, then we'll return false. And anyway, the idea is that now the client can't access this method, but we can access it. So for example, when we are creating this class, we can check that if ID is okay for the provided ID, then let's change it to this one. And if it wasn't, then let's set the ID to be something else or something like that. So again, the client can't access this method, but we can access the method inside the class. We just need to remember you used self dot something when we are accessing it in this case. So the same thing that we did with attributes also applies to methods. We can hide the access to methods by using 2 underscores in the start of the name like this. So if you try to call it from the client, you get an attribute error, then the student object has no attribute ID okay, saying that we can't access it like this. It's only meant for internal use of the class. Okay, and then as a final thing for today, a couple of words about static members. So in addition to having class member or object members like attributes and methods, we can also have a class members, and we call these static members. And these are not needed as often as we need attributes and methods, which we need for basically any class we are writing. But these are sometimes useful. And the idea of static member is that it's shared by all objects of class. So there's only one value for each class. And for student class, we could have something like what could we have? Let's have something like email domain, and it's going to be helsinki.fi for all the class, all the students created out of this class. It doesn't have an email, but we could let's add email address in here. Something like this. And now we can access this email domain from the client side, but we don't need to use any object for that one. We can just use the name of the class, like student, and then the name of the variable. And the reason I wrote this variable name in all capital letters is because that's the way in Python to announce that something is supposed to be a constant value. It's not supposed to change. The value of the email domain is supposed to be the same all the time. So writing a variable name, whether it's in class or somewhere else, in all capital letters means that it's not supposed to change. You assign a value to it once, and that value is supposed to remain throughout the program. So we can, we need to have one more attribute to Simon. Of course, we added Gmail, but other than that, we can now access this, and we don't need to create any object to access this value. We can just use the class name like this. So static variable is said, it belongs to the class, not to the object. And we write it inside the class, not inside any of the method. It's not an attribute of an object. It's just the value, or like a class variable. So as I said, these are not needed as often as we need attributes, but these are sometimes useful. When you have some information that is shared by all objects in a class, then you can use it. We can also have a value that can change. We could use something like this, although this is potentially dangerous. Anyway, I'm going to show it to you. So let's have a counter, and whenever we create a student object, let's increase the value of counter by 1. Let's create some students. And then let's output the value of counter. So it should be 1. And then when we create more students, like this, just change the name of the variable. Then the counter, the value of the counter increases each time, so it's 1, 2, 3, 4. So again, it's one shared value for all the entire class. It's not an attribute. All the objects don't have their own counter. There's just one counter in the class like this. But as I said, having sort of a counter like this can be dangerous because it's really difficult to count whether you're actually losing some objects, whether some objects are deleted. So it shouldn't be used exactly like this. But this now it keeps a count on how many objects we have created from the class. It doesn't necessarily mean that they are all still existing. In this case, they are, but it keeps a sort of reliable count on how many objects we have created out of class, which might be useful information in some occasion. Anyway, the basic idea is that there's only one counter for the entire student class and for all the objects created out of the class. It's not an attribute, but it's a class variable. And that's why when we access it, we don't use any reference to an object. Instead, we use the student class name and then the counter, like this. We can access the counter again without creating any objects. So it's going to be 0 eventually, and so on. It's also possible to have static methods. Again, those are not used as often. Let's have something like this, for example. Let's say that all students share the same school, and for static methods, the first variable is also always CLS, which is shortened for class. We can't use the name class because it's reserved for creating a class in here. So it's CLS, and then we can have any let's not have any variables for this one. Then output something like this in here, and we also need to annotate it to be class method like this. And again, this means that we can call the class method without needing to create any objects. So I can just type student dot output school name like this, and then it executes the method, and I don't need to create an object out of the class to do it. Again, as I said a couple of times, actually, you don't need, these are not needed as often as the object methods, but sometimes it's useful to have like a tool method in a class which can be used without creating any objects out of the class. Something like this. Class variable class. For example, this actually might be even more useful than that school name thing, which probably isn't useful at all. But we could have a class car, and then we can have a method for license plate valid, which we can use to check if any given license number is a valid license number without needing to actually create a car object for that one. Okay, do you have any questions about anything today? So we continue where we stopped last week. So encapsulation, the idea of using object references in other classes and storing them in the data structures, and then static members. So basically a lot of new stuff, but nothing of this should be too complicated. There's a lot of syntax to remember, so you probably need to write a couple of getters and setters before you actually remember how to do it. But then again, it's really easy to Google. If you don't remember what was the syntax for Python setter, it's like 10 seconds in Google, and then you know how to, or remember how to do it. Okay, if you don't have any questions, then let's stop.